Hi friends, welcome back to our YouTube channel. Today we have to discuss about DeMorgan laws in Discrete Mathematics and Graph Theory course. Let us consider P and Q are two propositions. The disjunction of two propositions can be denoted by P or Q. The negation of disjunction of two propositions P and Q can be denoted by negation of P or Q. Next one. For this proposition, the negation of proposition P can be denoted by negation P. Negation of proposition Q is denoted by negation Q. The conjunction of these two propositions, negation P and negation Q, can be denoted by negation P and negation Q. Now, the DeMorgan's first law is the negation of disjunction of two propositions P and Q is logically equivalent to the conjunction of negation of individual propositions, that is nothing but negation P and negation Q. So this is called as DeMorgan's first law. Okay, so whatever I am telling, that is the statement form, DeMorgan first law. Let P and Q are two propositions. The negation of disjunction of two propositions is logically equivalent to the conjunction of negation of two individual propositions. So that is nothing but negation of P or Q is logically equivalent to negation P and negation Q. Now, this can be proved by using truth table method. Okay, so in this one, what are the individual components are there? So P, Q, P or Q, negation of P or Q. Next one, negation P, negation Q, negation P and negation Q. So these are the individual components of the DeMorgan's first law. Now these individual components can be written in the truth table. Okay, how many number of rows that are present in the truth table? So how many number of propositions are there in the DeMorgan's first law? So there are two propositions, that are P and Q. With the two propositions, how many number of possible truth values we are getting? That is 2 power 2. So where 2 is nothing but number of propositions, that is 4 possible combinations of truth values of the propositions P and Q. Now, so I am taking first column contains P, second column contains Q, third column contains P or Q, fourth column contains negation of P or Q, fifth column contains negation P, sixth column contains negation Q, seventh column contains negation P and negation Q. Okay, so with two propositions P and Q, how many number of possible combination of truth truth values, we are getting 4 possible combination of truth values, that are p value true, q value true, p value true, q value false, p value false, q value true, p value false, q value false. Then what is the truth value of p or q? The truth value of p or q is false when p value is false and q value is false. Then p or q truth value is false. In remaining all cases, the truth value of p or q is true. Next, what is the truth value of negation of p or q? So that is nothing but we have to negate the truth value of p or q. So negation true is nothing but false. Negation true is nothing but false. Negation true becomes false. Negation false becomes true. Next one. Negation p truth value. The truth value of negation p can be obtained. Negate the truth value of proposition p. So p value is true, negation p truth value is false. P value is true, negation p truth value is false. P value is false, negation p truth value is true. P value is false, negation p truth value is true. Next, what is the truth value of negation q? The truth value of negation q is obtained by negate the truth value of proposition q. So if q value is true, negation q truth value is false. Q value is false, negation q truth value is true. Q value is true, negation q truth value is false. Q value is false, negation q truth value is true. Then what is the truth value of negation p and negation q? So we have to consider this column and this column, in between them. So and connective is there. So what is the truth value of and connective? P value is negation p value is true, negation q value is true. Then negation p and negation q truth value is true. Remaining all cases it is false. So negation p truth value is true, negation q truth value is true. True and true is nothing but true. In remaining all cases it is false. Now, so in this DeMorgan's first law, this is the logical equivalence symbol. Before the logical equivalence symbol, whatever the compound proposition is there, so that is negation of p or q. After the logical equivalence symbol, whatever the compound proposition is there, negation p and negation q. Okay, so this compound proposition is logically equivalent to this compound propositions when both are containing the same truth values. So now observe these truth values and this truth values. So negation of p or q truth value is false, 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 true. Negation p and negation q truth value is false, 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 true. So by observing these two columns, both are containing the same truth values. Hence, we can say that so negation of p or q is logically equivalent to negation p and negation q because both are containing the same truth values. In this way, we have to prove the DeMorgan's first law. Then we can go for DeMorgan's second law. We can go for DeMorgan's second law explanation. Let P and Q are two propositions. The conjunction of two propositions P and Q can be denoted by P and Q. The negation of conjunction of two propositions can be denoted by negation of P and Q. Next one. Negation of proposition P can be denoted by negation P. Negation of proposition Q can be denoted by negation Q. The disjunction of these two propositions can be denoted by negation P or negation Q. Okay. Now, the disjunction of these two propositions, negation P or negation Q, can be denoted by using this one. Now, the negation of conjunction of propositions P and Q is logically equivalent to disjunction of negation of proposition P and negation of proposition Q. Okay, so this is called as DeMorgan's second law. Negation of P and Q is logically equivalent to negation P or negation Q. Now we can go for the statement. Let P and Q are two propositions. The negation of conjunction of two propositions can be denoted by this one. Is logically equivalent to the disjunction of negation of the individual propositions. Okay, so this is the negation of P and Q is logically equivalent to negation P or negation Q. So what are the individual components are there? Two propositions P and Q. Next one, the conjunction of these two propositions can be denoted by P and Q. Negation of conjunction of two propositions can be denoted by negation of P and Q. Then negation of proposition P can be denoted by negation P. Negation of proposition Q can be denoted by negation Q. Disjunction of these two propositions can be denoted by negation P or negation Q. These are the individual components. This can be proved by using truth table method. In the truth table method, how many number of columns present? So these number of columns 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7 columns are there. How many number of rows present in the truth table? So number of propositions can be denoted by n. N is equal to 2. 2 propositions are there. With 2 propositions, how many number of possible combinations of truth values we are getting? 2 power n. So that is n value to substitute it, then we are getting 4. So 4 rows are present in the truth table. That means 4 possible combinations of truth values of propositions P and Q. Now, the first column contains proposition P. The second column contains proposition Q. The third column contains disjunction of P and Q. Conjunction of P and Q. Fourth column contains negation of conjunction of P and Q. Fifth column contains negation P. Sixth column contains negation Q. Seventh column contains negation P or negation Q. Now, what are the 4 possible truth values we are getting? That is P value true, Q value true. P value true, Q value false. P value false, Q value true. P value false, Q value false. These are the 4 possible truth values of propositions P and Q. Then, what is the truth value of P and Q? So, P and Q is false when P and Q truth value is true, then P value is true and Q value is true. Whenever P value is true, Q value is true, P and Q truth value is true. In remaining all cases, it is false. Then, what is the truth value of negation of P and Q? Negation of P and Q truth value can be obtained by negate the truth value of P and Q. P and Q truth value is true, negation of the truth value is false. P and Q truth value is false, negation of that one is true. P and Q truth value is false, negation of false is true. P and Q truth value is false, negation of that one is true. Then, what is the truth value of negation P? The truth value of negation P can be obtained by negate the truth value of P. So P value is true, negation P truth value is false. P value is true, negation P truth value is false. P value is false, negation P truth value is true. P value is false, negation P truth value is true. Then, what is the truth value of negation Q? We have to negate the truth value of Q. Q value is true, negation Q truth value is false. Q value is false, negation Q truth value is true. Q value is true, negation Q truth value is false. Q value is false, negation Q truth value is true. Then, what is the truth value of negation P or Q? Negation Q. So the negation P or negation Q truth value can be obtained by performing the disjunction between negation P and negation Q columns. So false or false is nothing but false. False or true is nothing but true. True or false is nothing but true. True or true is nothing but true. Okay. So this is the logical equivalence symbol. Before the logical equal symbol, whatever the compound proposition is there, this one, negation of P and Q. After the logical equivalence symbol, whatever the compound proposition is there, negation P or negation Q. So this is logically equivalent to this compound proposition is logically equivalent to this compound proposition whenever both are containing the same truth values. So what is the truth values of negation of P and Q? False, true, true, true. What is the truth value of negation P or negation Q? False, true, true, true. So both are containing the same truth values. Hence, we can say that this compound proposition is logically equivalent to this compound proposition. So in this way, we have to prove the DeMorgan's second law. Previously, we have to prove the DeMorgan's first law. I hope all of you understanding this video. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. In the comment section, I will give the entire playlist of Discrete Mathematics and Graph Theory course. Please go through this link and get all the videos and understanding the subject and get full marks in that subject. Thank you. Thank you one and all for watching this video. If you really understanding this video, please subscribe my YouTube channel, Divvela Srinivasa. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. So thank you once again for watching this video.